Good morning, everyone. I'm Amir Ali from the University of Plymouth, and today it's my pleasure to present to you a talk about research directions and areas of interest in artificial intelligence. I am a lecturer in artificial intelligence and robotics, and I am the AI program manager at the University of Plymouth, and I'm also serving as an AI consultant for some British companies. My research interests, I am the director and founder of the SOAIR Laboratory for Research in Artificial Intelligence and Robotics. So my areas of interest are the artificial intelligence, the wide area of artificial intelligence and its applications, robotics, different areas of robotics, big data, healthcare and e-health, and speech and language technology. One of the projects that I have been awarded last year, and it is a big project, £1 million GBP, British pound project, that aims to create four novel technologies. So co-design with digitally excluded people. We go to digitally excluded people and elderly people and try to involve them in the co-design of four technologies to let them feel integrated to the community and to let them entertain the community and the cultural landscapes. These four technologies are extended reality, social games, underwater telepresence, because we are a coastal community, so there is a lot of underwater places to discover while not being underwater, and AI voice interface, which allows people to connect to digital services through voice and phone calls without having broadband, which enhances inclusivity. So do you know that in China, about 70.8% of the population had been 60 years and older, and the number is increasing for 2040. And also, there are reports coming from China that there are the digitally excluded people, the percentage is being increased in the city and the rural areas. So a project like this can be so useful for the community in China. This video is just for publicity about the iconic project, and it shows you that how elderly people are participating in the co-design of the technology. We are using with them, for example, headsets for virtual reality to let them see places through virtual reality while not being there. This helps their inclusivity and give them kind of feeling of well-being. Another research that I'm interested in and have been awarded recently is research about autism spectrum diagnosis. So this project aims to use multimodal AI machine learning models to help the current efforts of the health sector to better and more accurately diagnose autism that's currently based on observations from psychiatrists. So only psychiatrists can diagnose autism based on observations, but we are trying to use machine learning models to efficiently support this health sector forward. So in this project, actually, we are developing AI models, and we are making experimental validation through autism support centers. So we will use real data to validate the models that we are developing and to make sure that they are interpretable and transparent models that can be used by practitioners in the healthcare sector. And do you know that in China, China is a home to some 13 million children and adults affected by autism. So actually, a research like this can help a lot also, or can facilitate collaboration and fits well with the Chinese environment, and can facilitate collaboration with academia and or health sector. Despite there is initiatives to use AI and machine learning for the diagnosis of autism, but the initiatives that have been done in this area are so far limited. Our projects try to go beyond these initiatives. One more research is about how to make robots understand language from scratch. When I ask a robot, for example, to understand a sentence like "bring my red cup," the robot can have observations to understand what is mean the word, for example, cup, and it will go to search it in the environment. So there are challenges here to make the robot understand a word like a cup and what does it mean also the word red here. If we will not give it a prescribed a priori knowledge about the environment. So it should go and discover or learn like the same way like babies, infants do. So this is a research project of understanding that aims to understand, investigate the computational modeling of language compositionality. Actually, the idea here of this EPSRC project worth a net of 83,000 British pounds is to investigate how language actually robots can build the knowledge from bottom to up, from word level to phrase level to sentence level, similar to how children actually learn language from scratch. So we don't want to give any knowledge to robots. We want them to learn from scratch, which is the objectives of our project. For example, language grounding. How can we create computational models that can help robots learn language and meaning of words from scratch? When I say through visual perception or through perception, it's something like this. When here I have a robot, the robot is collecting some information about object, for example, like bottle. What does it mean, bottle? So the robot tried to get some haptic information. The robot tried to get some auditory information. The robot tried to get visual information and tried to learn, associate this to the meaning of the word bottle. In the same time, we also try to build computational models for grammar induction to make a robot learn the meaning of a sentence. It needs grammar, and we try to understand how can the words compose together so that two words can compose together and create a phrase and then create a sentence. There are also other group of projects that I'm involved in is, for example, underwater biodiversity monitoring projects. We are using robots and AI to enhance underwater biodiversity monitoring. This is a project worth 90,000 GBP British pound. And this actually can help in supporting decision-making for policies protecting marine resources and mitigating climate change effects. There's also a project I'm involved in like human-robot teaming for long-term operations and maintenance of offshore renewable energy devices. So here we are speaking about, for example, using drones and how they can collaborate and team up with humans for maintaining, for example, wind turbines or like location in extreme environments, for example. And another project, industrial project that aims to develop speech technology for people with for deaf people that have problems in hearing. So it's we are creating a communication channel that can help them and for communication, and it can map sign language to text. There are actually more projects that I don't have time to discuss here about healthcare, big data, and robotics, but we can discuss for you if you are interested. So if you are ready to collaborate with me in the wide area of artificial intelligence, including healthcare, robotics, and agriculture robotics, big data, AI in education, smart manufacturing, and more AI applications, please contact me. Thank you for your attention.